Hello everyone, a very warm welcome to today's explainer. We are going to embark on a truly beautiful mathematical journey together today, unlocking the brilliant and logical world of geometry. I want you to imagine yourselves as detectives, my dear students, looking closely at shapes and uncovering their hidden relationships.
Created by MindSticks Foundation Trust.
Here is what we are going to cover today. 1. What are similar triangles? 2. The angle tests. 3. The side tests. 4. Properties. And 5. We'll solve some geometry problems together. Let's dive in.
Section 1. What exactly are similar triangles?
Technically speaking, two triangles are similar if their corresponding sides are in the exact same proportion and their corresponding angles are exactly equal. Now, if we did this the long way, checking all three sides and all three angles, well, that's 6 whole conditions. Doing that for every single problem sounds absolutely exhausting, does it not?
Take a look at the triangles on your screen, ABC and the slightly smaller DEF. If we checked all 6 conditions and they perfectly matched, we would confidently write triangle ABC is similar to triangle DEF using that little wavy symbol you see there. But thankfully, math is a brilliant subject. It gives us elegant shortcuts so we do not have to do all that heavy lifting. Let's look at those right now.
Section 2. The angle similarity tests.
All right, here is our very first shortcut, the AAA, or angle, angle, angle test. If you can prove all 3 corresponding angles of 2 triangles are equal, say angle A equals P, B equals Q, and C equals R, boom, the triangles are mathematically similar. The sides will naturally fall into proportion. It's a geometric guarantee.
Now, here is the really fun part. We can make this shortcut even shorter. Remember, the angles inside any triangle always add up to exactly 180 degrees. Because of that, if you just check 2 angles using the AA test and they match, that third angle has absolutely no choice but to be equal. So checking just 2 angles is perfectly enough to prove similarity.
Section 3. The side similarity tests.
Moving on, this diagram illustrates the SAS, or side angle side test. Imagine 2 pairs of sides are proportional, like a 2:3 ratio, and the angle between them is equal. Then yes, they are similar. But, my students, pay very close attention here. That angle absolutely must be included. It has to be tucked right between those 2 sides we're measuring, just like angle L and angle S here.
Our next big shortcut is the SSS, or side-side-side test. If all 3 corresponding sides of 2 triangles share the exact same proportion, you are done. You don't even need to measure a single angle. If the ratios of all 3 pairs of sides match up perfectly, the triangles are definitely similar.
Section 4. Properties of similar triangles.
Let's quickly go over the golden rules here. First, reflexivity. Every triangle is similar to itself. Simple enough, right? Second, symmetry. If triangle A is similar to triangle B, then B is naturally similar to A. And third, transitivity. If the first is similar to the second, and the second is similar to a third, well then the first and third is similar too. These are the absolute foundational truths we build our logic on.
Section 5. Solving geometry problems.
All right, it is time to put on your detective hats. We have some mathematical evidence to examine. Let's see if we can figure out if the next 2 triangles are similar.
Look closely at this image on your screen. We have triangle PMN and triangle UVW. Notice the numbers. One side is 6, its counterpart is 3. Another is 10, its counterpart is 5. We also know angle M is exactly equal to angle V. So how do we systematically tackle this?
Let's break it down step by step using our newly built toolkit. First, the ratio of the first pair of sides, 6/3, gives us a 2:1 ratio. Step 2, the second pair, 10/5, also gives us a 2:1 ratio. Perfect. Step 3, look at that angle. Angle M and angle V are equal, and crucially, they are sitting right between our proportional sides. Conclusion, the triangles are absolutely similar by the SAS test.
Fantastic work, but a good detective knows how to spot a trap. Let me present a trick question to really test what we have learned today.
Check out this new case file. Let's test the ratios. 14/21 simplifies to 2/3. 20/30 also simplifies to 2/3. Great. And angle Z is clearly marked as equal to angle P. So they must be similar by the SAS test, right? Can we just close the case?
Ah, not quite. Remember the golden rule we discussed? The angle must be included. Look exactly where angle Z and angle P are sitting. They are completely outside the sides we just measured. Because they are not sandwiched directly between our proportional sides, the SAS test completely fails here. There's just no way to say they are similar based on this evidence. Do you see how important that one little word, included, is?
Let's look at one final, slightly more complex puzzle. Here we have a quadrilateral where the diagonals cross right in the middle. We are given the ratios of those diagonal pieces. Now look at those two small triangles in the center. Notice anything? The angles right in the middle, where the lines cross, are vertically opposite. And from your earlier classes, you know vertically opposite angles are always equal. Combine that hidden equal angle with our proportional sides, and boom, the SAS test solves the mystery for us beautifully once again.
So, what does this all mean for us? Well, mathematics is really just a lens to see the hidden logic in the world around you. Similar triangles are not just stuck on a blackboard. They are literally holding up the trusses of bridges. They're in the shadows cast by the afternoon sun, and they're right there in the architecture of your very own home. Keep your detective hats on, keep observing the world closely, and keep calculating. Thank you so much for joining me today. Happy learning.